11.2 on gas pressure. Pressure is a push, it's force caused by gas. If you're going to have a gas pressure, then you're going to have a force pushed by that gas. The one that you're probably the most familiar, maybe not know, but at least you've felt it all your life, is the atmospheric pressure. All of the gases above the earth, there's about 100 miles-ish of gases above you, and they are pushing on you to a point where that you feel that pressure. Okay, that's it's called atmospheric pressure. There's about 14.7 pounds of pressure for every square inch of skin on your body. The air is actually shoving on you. If you were then to go into the water and dive under the water and the gas above it, so the air above the ocean plus the ocean would be shoving on you. So if you go down deep into deep water, you have serious pressure put on you. Well, that could do weird things to your physiology, okay? Because you have pressures on the inside of your cells, and the pressures on your outside of the cells need to equalize. So it would do funny things with your ears. Have you ever traveled up into the mountains and your ears pop, okay? Or go down from the mountains and they plug up? What's happening with the pressure has to your ear can feel that pressure and equalizes. So the atmospheric pressure of the gases above you is called 1 atmosphere. Now there's several ways of measuring the pressure of these gases, but 1 atmosphere is essentially how much air is above you if you're at sea level. So normally at sea level you would have 1 atmosphere of gas. Okay. So we know that the pressure is the force that the gas exerts on the surface of the chamber, so on the lid and on the floor and on the sides, and the volume is how much room it takes up. The temperature has a lot to do with how fast that these molecules are moving and how much they push, because if they're bouncing off of the wall, they've pushed on the wall every time they hit it. If they push on the floor, then they're bouncing on the floor, they push on the floor. If you can remember back in 2nd grade gym class and everybody played under the parachute, and all the boys went under the parachute and started punching with their fists up on the parachute to keep the parachute from dropping down on their heads. Every time they slammed into the parachute kind of went out a little bit. Well, that's exactly what's happening with a balloon. The air molecules are bumping into the sides of the balloon, and every time they bump, they're pushing it. Now, if you speed up the rate of those bounces by making the temperature higher, then what will happen? That same amount of gas will push more on the sides. It'll bump more frequently into the sides of the balloon, and the balloon will expand. So the volume of the balloon has a lot to do with its temperature. That's interesting. And then the amount of gas, that's the amount of moles, we'll talk about moles later, the amount of gas present in a unit called moles is how much gas is actually there. So if you blow up the balloon by putting more air into the balloon, then the balloon will expand, not because it's hotter, but because there's more of it shoving into it. Okay. Now, oh my goodness, there's so many ways to measure pressure. I don't know why. You'd think 1 or 2 or 3 or 5 would be good enough, but there's more. So we already talked about atmospheres. The amount of push that all of the air at sea level has above you is called 1 atmosphere. Really, the most frequently used unit has to be something to do with a barometer. So a barometer is a measurement tool for air pressure. So originally, a barometer had a chamber of mercury with a vacuum above it in a dish of mercury, and then as the air pushed on the mercury, it would shove it up the test tube, and that could be measured. We'll look at that in just a second, but that's called mm of mercury. Hg is the chemical symbol for mercury, and millimeters of mercury is how many millimeters did it shove up that barometer by the air pressing on the dish of mercury that was exposed. Torr is the same. One torr, which is named after a scientist, is equal to 1 millimeter of mercury. So they just named it after the guy. Okay, you could do inches of mercury, you could do pounds per square inch. I told you 14.7 pounds per square inch was equal to 1 atmosphere. Okay, pascals, kilopascals, these are other units. There's even more. There's a bar, a millibar. There are even more than that's on this. Can you believe it? How many do you need? What is 475 millimeters of mercury expressed in atmospheres? Well, from the previous slide, and we would have to look at this, 760 millimeters equals 1 atmosphere. So you would take the 760 millimeters and put it on the bottom, put 1 atmosphere on top, then cancel it and divide. That's how you would do it. Pressure in the tires, 2 atmosphere, what's this in millimeters? Well, 760 millimeters of mercury into an atmosphere, so you take 1 atmosphere on the bottom since you're canceling it, put 760 millimeters on top, and then multiply. And that's what we're doing here. You can see the answers, and we'll do these in class. So here's the old-fashioned barometer. Problem with this is liquid mercury is carcinogenic. It causes cancer, and it's very fun because it's very, very dense, and so it rolls around in your hand. It's very heavy. Everybody in the world likes mercury. There's nobody that wouldn't play with it if they could. Problem is, having mercury sitting in the palm of your hand soaks into your hand and does weird things with your DNA that we don't want to do. Okay? But I will tell you, I did it when I was in school. That was before people cared about people's health. In any case, it rose up a glass tube, and it was graduated with little marks on the side, and every millimeter it rose up was a torr. That was a torr of pressure that the air was pushing down, the gases of the atmosphere was pushing down. Okay? All right, so these are the units again. We've seen it before. 1 atmosphere is 760 millimeters of mercury, which is 760 torr, which is 101 Pascal. Okay? So the higher you are, the less air is above you. That means your pressure goes down. So you go up in an airplane, you have to have pressurized cabins. You have to pressurize it because you would be very uncomfortable with very low pressure because your head would hurt because you have pressure on the inside of you that would be more than the pressure on the outside. Your eyes would feel like it was wanting to pop out. Your cheeks would feel like it was popping out. Your head would throb. So you would need to pressurize that cabin. The lower you are, the more the pressure. So if you were to go somewhere lower than sea level, such as maybe, I don't know, Israel's like that, the Dead Sea is lower than sea level, then you would have more than 1 atmosphere of pressure on you. Okay, that's because you're higher than sea or lower than sea level. The downward pressure of mercury in a barometer is blank than the pressure of the atmosphere. Okay. Well, since it doesn't move, it's the same, right? So if it's heavier, then it's going to drop in the test tube, and it will be lower. If it's less than the atmosphere, then it's going to rise in the barometer, and if it doesn't move, then it'll be the same. So I'm not sure of the question here. A water barometer is 13.6 times taller than a mercury barometer because, what do you know about the density of the material? If mercury is very dense, forms balls in your hand, rolls around because it's really dense, water's less dense, so you need a bigger chamber to indicate the difference in pressures. So it's less dense. All right, hope that helps you.